All right, good evening, everybody. Welcome to WF40 First Look. If you are not intending to be at WF40 First Look and you're intending to go to Indianapolis, you're in the wrong room. I'm Kenny Wolf. I'm an architect on WCF and WF. This is my esteemed colleague, Kirill. He is a PM on WCF and WF. So out of curiosity, how many people in this crowd are using Workflow to build their applications today? All right. How many are not using it yet but are planning on using Workflow in the future? All right, great. Well, familiarity with Workflow is not required for this talk. I will be starting from first principles to introduce WF. However, there's a lot of you who have been using or are planning on using WF, and you're probably here to find out about the new features we're adding, and of course, I will be covering that as well. So let's talk about how you're going to spend the last hour of your day at PDC. First, we're going to go into the basics of Workflow. Then we're going to spend the bulk of the talk on why, when, and where you're going to want to use WF. And while we'll be introducing new features along the way, I'm going to conclude with a survey of some of the more impactful and larger features that we've added to WF40. So to start, what is WF? Well, Workflow is another way of writing programs. It's a way of writing programs that reduces the amount of complex code you need to do in order to coordinate work. Workflow consists of three parts. The first is activities. Activities define a unit of work in the workflow system. Activities are arbitrarily composable, and when you compose a bunch of activities together, the topmost activity in that composition we call a workflow. Think about public static void main. It's simply another function, but by denoting it as the entry point to your system, the CLR knows to start with public static void main as its function. Similarly, when you pass an activity to the workflow system, we treat that activity colloquially as a workflow, simply meaning that is the topmost activity in the composition. Activities have no dependency on thread local or CLR stack state. This allows them to be persisted and then rehydrated later. All in all, activities execute in pulses of work. They behave a lot of the time like college students. They laze around most of the time, hanging out, drinking a beer, and then some external input comes in, like, oh, a final exam. They burst into activity, a flurry of work happens, they've responded to that input, and then they go back, kick it, relax with a beer. And that really is kind of how activities work in this world. WF ships with a rich set of activities, and we encourage you to write your own as well. Lastly, activities are written as structured data, such as XAML. Activities can both be configured as well as written entirely from whole cloth using XAML. The second piece of the WF system is the workflow runtime. The workflow runtime is a lightweight, resumable execution engine for activities. Just like when you wrote managed code and you started executing your programs on top of the CLR, the Common Language Runtime, the CLR took care of memory management and type safety for you. Similarly, the workflow runtime provides services such as persistence and concurrency management to your workflow application. The workflow runtime can be hosted in a variety of application models, such as Windows Communication Foundation, Windows Presentation Foundation, and ASP.NET, among others. And it will add all these features in those various hosting environments. Now, the last piece of workflow is a set of tooling. This consists of a Visual Studio hosted designer and debugger so that you can interact visually to both author and edit your workflows. And when you're in the process of developing, you can then debug these workflows using an integrated visual experience. We have an extensible designer framework so that when you write your custom activities, you can also write an associated custom designer. In addition, you can replace the designers that we ship associated with our built-in activities if you want to skin them or adapt them to your needs. Lastly, all of this tooling is available to be rehosted in non-Visual Studio environments, thereby allowing you to control the end-to-end experience and customize it for your users. So in summary, workflow is art. activities, runtime, and tooling. Now, activities play a central role in this system. As I mentioned earlier, activities are the primitive unit of behavior in dubf. Data flows into and out of activities using arguments. Arguments define the activity's signature. Arguments have a direction, a type, and a name. Activities can be composed together into higher level activities. In this case, I've composed delay and receive message into parallel, and those will run in parallel branches of execution. And I've composed the other two activities together as well. The extensibility model of activities, combined with this composability, allows you to write rich control flow mechanisms, such as state machine, flowchart, which are not possible in a closed language, such as C# or VB. Now, when data needs to be stored across activity boundaries, that data is stored in variables. Variables provide a place for you to store data at any scope that is a composite activity. Activities can bind their arguments to any variables that are in scope. So for example, generate order can bind its arguments to variables either on sequence or state machine, whereas send report can only bind its arguments to variables on state machine. Lastly, the variables and arguments of the currently executing activities define the active state of the workflow. What this means is only that state will be persisted to disk, and other state will be cleaned up as the activities finish their execution. Now, activities let you customize the vocabulary for your domain. dubf ships with a rich palette of activities out of the box. We have a set of control flow activities. This includes flowchart, state machine, parallel, sequence, and more. All of these control flow activities can be arbitrarily composed together. So just because you choose to start with a state machine doesn't mean that for a subset of your work within that state machine, you can't use either another state machine or a flowchart or a parallel and so forth. We also ship with a BCL of activities that we call the base activity library. The base activity library provides a number of primitive dubf activities for interacting with the system, such as cancellation, transactions, persistence, and termination. In addition, we provide integration activities to systems such as PowerShell, databases, and we provide a rich set of WCF messaging activities for when you want to write a workflow that happens to be a service and integrate with the WCF system. We have a number of customers today that are building on top of workflow. You may have heard of SharePoint's usage of dubf in Office. Using Team Foundation Server, you will be able to use workflow to construct build processes. And Dynamics has built a full customized experience on top of dubf, and they'll have an entire lunch session tomorrow to talk to you about what they've done. And lastly, we look to you guys as the developers to write custom activities to continue to extend this ecosystem. We're giving a talk, another dubf talk, on writing custom activities this Wednesday, courtesy of Matt Winkler. I encourage you all to attend. Matt's going to go into the next level of detail about how you will go about writing custom activities in this system. So with that set up, let's show you what it's like. What we have here is a flowchart activity. I wrote a workflow this weekend that is for our PDC promotional prize application. And the way this application works is, well, we start, and then we prompt the user for a question. We see if they're paying attention during this talk. So if they've been paying attention, and they get the answer correct, we're going to go to a decision point in the flowchart. In the case I get the answer correct, we're going to move on with our workflow. Otherwise, if you get the question incorrect, since we're feeling generous, we just ask you the question again and let you try again. So when you finally get the question right, in parallel, we will send you the claim code for your prize, and we will ask you, what is your claim code? Waiting for you to enter your claim code that's an exact match. We've encapsulated that looping behavior that checks for a match and continues to prompt you in a custom activity called prompt exact. Finally, when you've both received your claim code and entered it successfully into the system, we'll actually get you your prize and deliver it to you. So we did this by dragging a bunch of activities onto this main canvas that you see here. What we did is we took activities from the activity toolbox. The activity toolbox is not available on MSDN, but will pop out from the side of your Visual Studio window. And you'll see not only the set of built-in activities in the middle, which have these pretty custom icons, courtesy of our design team, things you'd expect to be provided, such as parallel, the core flowchart as well. But also, when you build activities within your solution, those activities get added to, in this case, we see dubf demo components because the solution is the dubf demo. And this is my custom prize activities, such as get prize, set prompt info, a number of activities I needed to write in order to finish this workflow process. So what I do is I write some activities, I drag them onto my composite activity to generate a new activity that I'm going to use as my workflow. And then I have to parameterize that workflow because it's going to be taking some external inputs. So I bring up the arguments window. And in this case, I've added 3 arguments. 1, the claim code associated with this particular instance of the workflow. Each instance is associated with a particular prize that can be claimed by a particular user that the workflow has been started for. And finally, as you saw, the end of the workflow gets the prize, and it's going to bind it to the out argument, again of type string, called prize. When authoring my workflow, I'm going to bind the arguments of different activities to either the outer arguments of my workflow or to variables, which are available to a very similar looking window showing me my variables. Now, the variables window allows me to define new variables, and it also allows me to show what variables are in scope. This is very helpful if I'm down deep within my workflow and I want to see what are the variables available to me. That's shown in the top section. Lastly, to bind these things, I go and I bring up the properties pane. So for example, on sendMail, I'll look at the properties of sendMail, and I'll be able to bind those to in-scope variables, perform expressions on those in-scope variables. And in this case, what you'll see is I'll be sending mail with the claim code. You see the host name and password. If you want to leverage this account, act now. I will be disabling it after this talk. And you'll get mail from winbig@pdcprizes.net. So we've put the workflow together. We've bound our arguments to various variables. And now let's run this workflow and see it in action. Now, first, a little stipulation here. I'm a server guy. There was a time when I worked on Office for the Mac, and I did a bunch of fancy UI. But those days are over, and I've been more tied to console apps lately. And the way this program is going to work is I'm going to enter my email. Well, Kirill is going to enter my email. And what this program is going to do is, based on the usage of this program, if a workflow instance exists for KennyW at kennyw.com, it will load that workflow. Otherwise, it will create a new instance and associate it with this username. And so it's going to ask me a question. What is dubf? And if I had been paying attention, I would know that dubf, well, it's not really, is it an animal, vegetable, mineral? It is not a fruit. But dubf, it was activities, it was runtime and tooling, which I believe meant that dubf was art. So can we try that and see if I can win a prize? Sweet. So now the workflow has gone past the initial question. I've broken out of that decision point. And hopefully at this point, right, I'll have received my prize code. And networks are working. The goat sacrifice at the beginning of the session was successful. And I know that my prize code is now Open Sesame. Perhaps I could have figured that out. But so now I'm going to go. I'm really excited. I'm going to be able to claim my prize, enter Open Sesame, and dude, where's my workflow?
Oh, sorry, Kenny. Demo jitters.
OK. Now, we've been using workflow to build our entire app. And one of the things our host has done for this workflow is at idle, it decided to have a policy of I'm going to persist on idle. And since our application was idle, waiting for me to enter this input for the prize code, I'm not going to have to rack my brain and figure out that initial question, try and reassociate the prize code, because what's going to happen is when I relog into this application, it's going to find the existing workflow that had been persisted, load it up, and now I'm still at the stage where I left it before. That is to enter my prize code and claim my fancy prize. So open Sesame, and let's see what PDC-08 has to offer me. Yes! Everyone always wanted translucent rectangles. So what you've seen here is in a fairly simple app, you would think, there's actually some complexity going on here, right? We did some long-running asynchronous work by sending a piece of email. We did some parallel coordination by both sending that email at the same time prompting the user so that we didn't have to wait for one of these things to happen before the other. And lastly, we were resilient to failures in case your code monkey happens to have the jitters because he hasn't spoken to PDC for a while. So it's great. You use DubF if you want to author PDC demo apps. But PDC only happens every couple years. You're probably doing something in between. So let's talk about why else you might want to use workflow. And there are 4 broad categories of applications where you're going to want to use workflow, or consider it for your use today. The first is when you want to coordinate work. Now, as you saw, workflow made writing that demo application much easier because when I wanted to coordinate the asynchronous work of send mail, when I was waiting for user input, and I wanted to encapsulate all that logic in a single context, workflow took care of the complexity of all of that reassociation, the pause idle points, coming back, persisting, and made it very easy for me to focus on my business logic and not worry about the details and the complexity about coordinating work. The second type of application, as you saw earlier, is if I want to write a persistable application. Right? Some applications are transient, but for applications where I'm going to be doing a little longer running work, or maybe the work isn't that long running, but someone might have the jitters, workflow provides you with a very natural way of adding persistence easily to your applications. The third broad scenario where you want to consider workflow is to gain an extra level of visibility into your application. As I mentioned earlier, workflows are authored using structured data. And the beauty of structured data is it up-levels the experience and the articulation of your program's content so that people can provide rich tooling on top of this. You're going to see some examples later in the week when we talk about the Oslo tooling set that really lights up this programs as data. And lastly, when you want to customize the vocabulary and the full design experience for your application, workflow provides a very natural way for you to do that. So to provide you some more details about what workflow is doing under the hood for coordination of work, let's take a look at a simple program. What we have here is one step beyond Hello World. And this application is going to get 2 pieces of input, first a username, and then a password. And when it has those pieces of data, it's going to then validate that the password is correct for this user. And what happens is when I run this application, it's going to hang out for an arbitrary amount of time because I'm using the console, and that's OK. Now, this application consists of 3 main components. First is a set of state, represented by my local variables in this case. The second is I'm getting a bunch of input from the console and associating it with these pieces of state. Lastly, I'm wrapping all of that logic in a control flow mechanism, in this case, sequence. Now, if I want to take this application and now push it out to the web, let's say I want to fill out a form with my username and my password. If I put this program directly on my hosting provider, he'd shoot it in the head, because I can't let my web-hosted program hang around arbitrarily waiting for input. So in order to adapt my program to the web, I need to break this logic up. And when I break this logic up, I have 2 discrete components. The first is getting the user information, and the second is getting that password information and validating it. And so I've broken apart the inputs from these islands of code, and we have technologies such as WCF and ASP.NET that will help associate these external inputs with your islands of code. However, since we've lost that shared context, I need to explicitly add my state management. And so I have code within these islands to store my state off to the side and push state in there, as well as pull it out depending on what my operation is. And if you notice, I now have the core of the logic, as well as the state management, but I'm missing that cohesive control flow that articulated I wanted get user called first, followed by get password. And so I can add that logic as well. With more code, more state management, I'm now validating what's been called when, storing that state again on the side. And what I have here is a program that is exactly the same as that original program. But think about that. Look at the simplicity of the original program I had versus the complexity necessary now that I'm putting this program in a distributed fashion. Now, I used services to articulate this point, but for those of you using asynchronous programs, you deal with similar problems every day. I'm marshaling state through an async callback, in another async result. I have some embedded async results. And the logic of your program is getting lost in all this complex coordination logic. And the beauty of using workflow to author your programs is workflow pushes the complexity of this coordination into the platform. I can focus on my program logic without having to sacrifice performance and scalability. And I still get clarity of intent for my program. Now, often when I'm coordinating work, the ability of the dubf system to both handle that complex coordination as well as serialize and deserialize in-flight instances makes workflow a natural application for persistable applications. And this provides me two main benefits. The first, as we've seen, is resiliency to failure. And the second is, when a program is not active, I can boot it from memory, right? And I can focus my resources on the programs that are actually doing work at a particular moment in time. Now, the key thing to remember about persistence is that persistence enablement comes for free. In the system, you don't have to pay for persistence from a performance perspective or from a footprint perspective unless you're actually using the feature. However, workflows are persistence enabled for free. If you want fine-grained control over performance, you can do that. The facilities are available to you. We have customizable persistence providers. These determine both the format and the store for your persistent instances. Persistence, just like garbage collection on the CLR, is primarily handled by the system. Stay out of it. You can call the various gc.xxx's. You'll probably be getting in Patrick Dessou's way. Similarly, in general, you kind of stay out of persistence's way, and you let the host policy deal with persistence. There are cases where maybe you're calculating pi to 30,000 digits. You've pegged the CPU for 2 minutes, right? That's a repeatable operation, but you really don't want to use the CPU for another 2 minutes, so you might, in that case, put an explicit persistence point. And if you want to do so, you're certainly welcome to do it. We have added support for no persist zones. As you saw, I was doing a volatile operation when I was sending mail. Right? The send mail was going asynchronous, and the socket call eventually would complete and release that resource. In order for your workflows to be able to integrate with such volatile asynchronous operations, we've added support for no persist zones. So you can go tell the workflow, hey, don't persist me now or bad stuff's going to happen. Your program might still get shot in the head. Your persistence point will have been earlier. But the workflow system will not let you persist during that no persist zone. Then when your asynchronous operation completes, you can say, hey, runtime, we're good to go. You can persist me at any point. Lastly, once I'm dealing with long-running, persistible applications, requirements may change. Workflow helps you deal with that eventuality by adapting to midstream process changes. You can update the program on the fly, associate these programs with your instances, and the instance can get an updated program that adapts to these changing requirements. So to give you an example of persistible applications, we're going to go back to our PDC 08 prize promotion app. And what you're going to see is, when we run the application, I'm going to enter my email again. I'm feeling lucky. There's a new promotion out. Every 5 minutes or so, this promotion resets so that I have a new chance. And now it said, oh, great. We know you're at a different point in the talk. So let me ask you a question about persistence. How much does dubf persistence cost me? Well, it's a pretty cool feature. It takes care of a lot of complexity for me. I'd pay 20 bucks for that feature.
Your money, Kenny. Anytime.
Huh. OK. That's right. It's what does persistence cost? OK, so I'd be willing to pay 20 bucks, but it turns out that's right. Persistence doesn't cost me anything. So is persistence cost me nothing? Zero? It's free?
Well, let's try it out. I think you should pay 100 or something. Oh, you're right.
Persistence is free. Great. Now we can claim our prize code and see what the persistence prize is. So let's go to kennyw.com/mail and fetch, not KWNE or otherwise, it's not going to work. All right. The way the alphabet works in Eastern Europe is slightly different than in America.
Kenny. We had our luck with network. No more.
OK, those of you speaking at PDC in the future, always remember to check your network before you run your demos. But now, Kirill, OK, fine. So I'm not going to be able to get my prize code.
Yeah, no luck. Sorry.
But hey, dude, there was no need to kill the app.
You don't know the answer. You don't have the price code.
But Kirill, you have access to the workflow program. I just told these guys that we can adapt to changing requirements. In this case, the changing requirement is the network's down, you like me. Maybe you should always let me win without having to enter a claim code.
I don't know. I think Kenny, PDC is a very strict event. All the demos were approved a week ago.
I have a speaker badge. It's in the bag. I can get it out. I'm a speaker here. Aren't we supposed to get? Guys, what do you think?
Just because Kenny, you are my friend, and you're the speaker, 20 bucks.
All right. Well, since persistence was free, I do have 20 bucks left over. Turns out not everything in life is free. So Kirill, if I give you this $20, will you update the program to not only check if the claim code is right, but if it's me, just let it through?
Well, let's try. I'll take the money, and then we'll see.
Hey, Bob, can I expense that? No.
All right, so we are the place where we are checking for this price code is in this prompt exact activity. And what we're going to do is we're going to open up that prompt exact activity. It's a simple while loop that is conditioned, that is going to loop and ask you to prompt, and until the following condition is true.
Until it's false. So while the input hasn't matched, it's going to just keep going. OK, so what if we just change that condition and say, for Kenny, if it's always false, so we always break out. Because then what we can do is when I log in, we can reassociate this program with my instance. Now, let's bring up the persisted form so we can make sure we're at a right spot for this dynamic update. And I believe, let's take a look at what the
Oops, wrong one.
So it turns out that the GUID in his memory on his command prompt is not actually the new workflow. Shocking, since there's a new GUID every time. Now what you'll see, based on this persisted form, is yes, turns out we're actually in prompt exact right now. We're not executing the condition, and since we're not actually in the process of executing that condition, we can update it dynamically. So,
I can't see anything, but I trust you.
Once you've been reading these things for about 2 years, blonde, brunette, no problem.
So Kenny, I'm going to run it, but do you remember your code, though? Do you remember the answer to the question?
No, but it doesn't matter. Workflow persisted, as I told you. We're sitting in prompt exact. We're long past that point. So all I need is to load up the instance using my user ID as the key to the system. And it's going to say, what's my prize code? And now, when it asks me for the prize code, I could just go I don't know. It doesn't matter, because I do know that I paid Kirill 20 bucks to be able to get this prize.
That's what 20 bucks give you. Let's see. Yay! 20 bucks, or anyone? Circles, 20 bucks? No? All right.
And so what you've seen is workflow not only lets me write persistable applications, but also lets me adapt to changing conditions over time. For the third major scenario for using dubf, let's talk about visibility into your application. Turns out, everyone loves software when things go right. It's when things go wrong that people get unhappy. Now, blue screens don't necessarily happen often. When they do, people don't like it. And the pathology of dealing with software is very difficult still today, even with rich debuggers available to us. The IT pro, he sees a red light. He sees something's wrong. He starts breathing down the dev's neck, right? The dev is the one who wrote the program. He should know everything. So he goes, what's going on? Or maybe the business manager for my prize app, he says, there hasn't been a big uptake in promotions. He doesn't realize maybe transparent rectangles are a thing of, earlier part of the century. But, he thinks that maybe it's a problem with the application. So he comes on the dev. Hey, why are people not claiming their prizes? Why are we not getting the uptick I'm expecting? Or maybe even you, the developer. You wrote this code 2 years ago. Or you wrote it last weekend, but you had a couple too many beers. What's that code actually doing? Well, workflow helps you with this process. As I mentioned, your workflows are authored as structured data. And the ability of up-leveling that experience lets you not only inspect the program, but your workflows are tracking enabled for free, and you can associate various tracking data with the structured data that defines your program. Again, just like persistence, workflows are tracking enabled for free, but you only pay for it when you're using it. You don't have to decide that you're going to use tracking up front. You can add it dynamically to the episode of loading and running a particular instance. You have extensibility around how you track this data. And your tracking data is integrated with both the WCF and the Windows E2E tracing. So if you want to figure out what's going on across multiple nodes of your distributed application, that coordination and that correlation is available to you. We've also heard from a couple customers that you might want to see some insight into what's stored in these opaque workflow instance blobs. While I've had a couple years of reading them, not a lot of people can say, hey, that's the state of all my purchase orders. So we allow you in dubf 4.0 to schematize variables within your workflow. So let's say you want to store your purchase orders in a particular purchase order table to be able to run rich queries over what's outstanding. You can do that with dubf. So now we've covered a lot about the why of dubf. Let's go into some details about some of the major features we've added in dubf 4.0. Turns out we've added some transformational improvements across the board, across activities, runtime, and tooling. In the activities arena, we've made authoring significantly simpler. It takes a lot less code to write various control flow activities. You'll see in the extending custom activities talk on Wednesday, Matt's going to write a pretty complicated parallel replicator style activity, or he'll write a different complex control flow activity. I don't want to steal his thunder, but he's going to do this on the fly for you, something that really wouldn't have been achievable in the previous version of dubf. As I've mentioned multiple times earlier, everything is fully declarative in the system. From your event handlers, to your data management, to your activities, to your conditions, to your expressions, fully declarative support through and through. We've aligned all model behavior around activities. No longer do we have silos for expressions, rules, other types of behaviors. The top level activity is not different from the sub-activities. We've provided full alignment across these technologies, and you can model all behavior as activities. And lastly, we have seamless composition across the various control flow styles. You don't have to be an iEvent activity to use something within a state machine. Right? There are no restrictions on that composability. In the runtime space, we've dramatically increased performance across the board. From execution speed to persistent size of your instances, our customers have seen, our early adopters within Microsoft have seen orders of magnitude differences between 10 and 100x across the board. As I mentioned earlier, we give you full control over the persistent system. We've separated persistence from unloading. So just because you want to persist your instance does not mean it needs to be booted out of memory. And we've added some much asked for features such as flow-in transaction support when using WCF, partial trust enablement if you want to host your workflows in a partial trust environment, and integration from a sync context and data context perspective into the various application models. On the tooling front, there have again been some transformational improvements to the designer and debugging experience. From a designer perspective, we've decoupled the association of activity designers with your activities. No longer do you have to subclass sequence because you want your sequence designer to look different. We've made it much easier to write your custom activity designers. For example, that sequence designer that you would occasionally replace took 800 lines or so of pretty hard C# code. That same activity designer that you saw earlier for sequence, well, not the same one, but the new activity designer for sequence, 20 lines of XAML. Done. Lastly, in the rehosting space, rehosting used to take about 20 pages of documentation before you even got to the code sample. Now it's 3 lines of code. Matt's going to demo that for you as well in the custom activities talk on Wednesday. And lastly, as part of this unification of all behavior into activities, you have a unified debugging experience across all these things. You can step into your expressions. You can step into your conditions. You can step into your modeled XAML-based event handlers. And you get a rich, unified experience for your debugging of workflows. And this is by no means a comprehensive list, but it is a highlight of some of the features that will be available to you in WF 4.0. Now, you may be thinking, these are some pretty big features. And you're right. We made a bunch of investigations on simplicity, on the data flow, on the fully declarative model, and looked at adapting them on the existing artifact. But it turns out we actually could not make these transformational improvements on top of the system that we had built. So what we did is we started from the ground up, built a new system with these transformational improvements from scratch. Now, what does that mean for you? You have WF 3.0 today. You should continue to use WF 3.0 today. 3.0, 3.5 workflows, they will continue to work. They will execute on the 3.0 workflow runtime. We are revving all of the existing bits to run on top of CLR 4.0. They will ship as part of the .NET framework, revised on top of the new runtime. If you want to use a 3.0 activity within a 4.0 workflow, you can do that as well. We provide a facility to call the 3.0 activities within your 4.0 system. And we're providing a lot of guidance on how to prepare your 3.0, 3.5 code. We have a number of internal customers, as I mentioned. There are early adopters. There are guinea pigs. SharePoint has started on this effort. Dynamics, as you see tomorrow, has gotten fully functional parity for their system. And we're learning from their experience. And we'll share those experiences and the top-level guidance with you, our customers. We'll provide a paper on how to prepare your activities. We'll provide case studies based on these early adopter experiences. And we'll be upgrading all of our existing 3.0 documentation to reflect these best practices. In particular, there's one area I want to call out, and that's around code activity. As you've seen, we've made a big push and a big pitch around the fully declarative model. Code activity and code beside run directly counter to that. Right? If I have a bunch of code activities, they all look like they're the same thing, but they're really doing fundamentally different things. Right? So I encourage you, as you're writing new activities, and depending on the code activities you have today, as you're adapting existing activities, take your custom logic, encapsulate it in a custom activity that'll do orders of magnitude for preparing you to move to the WF 4.0 system if and when you choose. Okay? Finally, one data point to indicate some of the upside that comes to you if and when you do decide to rewrite your 3.0 activities. As I mentioned, Dynamics is the furthest along. They have full functional parity. What they don't have is full line count parity. What they've seen is a reduction of 80% of their code in how they authored their custom activities when they moved to WF 4.0. This is due to the removal of a lot of the complexity around managing substates of activities. You no longer have to explicitly call close activity. You don't have to say, hey, I'm still executing or I'm closed. The system knows. It can figure that out. It takes care of it for you. Even when writing code for custom activities, you focus primarily on your logic. The system handles that complexity. So, to show you how we'll be bringing your assets forward, let's go back to our promotion app. And it turns out, as I mentioned, we haven't been getting that much uptick. People aren't into translucent rectangles and circles this year, it seems. So we decided we're going to go back to our tried and true prize generation activity that we used at PDC 05 3 years ago. And that prize activity, we had contracted out to a third party, a guy named Joe. And what Joe the developer did is he gave us thank you. Nothing gets by you guys. He gave us a compiled DLL with that custom activity that generates the prize that the top-rated prize we actually got in PDC 05. So, Karel, let's get rid of this lame 4.0-based get prize activity. Sorry, it's not lame. The activity that was not as well received as we would have liked. And let's drag the interop activity from the palette into our canvas. And what I'm going to do is I'm going to go to the body type. I'm going to click to browse my activity type. And based on that activity type, which in this case is going to be Joe's PDC 05 get prize activity. You see it in the recent items, because we've practiced this demo once or twice. Otherwise, we could browse for types using the type browser, which we might have to do. So, like I said, we go into the PDC 05 activity, which is one of our reference assemblies. We choose the get prize activity. And when we choose that get prize activity, we're going to then hook up the end of the parallel to that interop activity. And we're going to click on the interop activity. The properties on that interop activity, we're going to click off of it and click back on it and try again. Sweet. And what we see are the properties on this interop activity have been generated by the type of the activity that we imported, that we're interoping on top of. We looked at the dependency properties on that existing activity. We noticed that, to the best of our knowledge, there was a prize property of type string, a result property where we can output the prize. And we're going to wrap that existing activity with a 4.0 activity that has arguments that can be bound to the state that any other activity would be able to be bound to. So we bind it to the prize, and let's run again. Turns out prize has a default behavior which will give us the most popular prize of that activity. So we did not ask for a particular one. It allows us to choose from an array of prizes. Very rich activity that Joe built. And while we wait for our early alpha build to load, we're going to enter our email again. And now we have a new instance for the interop-based prize workflow. And it's going to ask me a new question, which is, can I use my WF3.0 activities in WF4.0? Right? The answer, as we said earlier, an emphatic yes. Let's all caps, exclamation points, whatever we need to make that point hit home. And now we have our new prize code. Let's refresh our account. And Open Sesame 2005. All right, we see some commonality among the prize codes used over the years. So we enter our prize code, and then we'll get to see the results of Joe's stellar activity, top-rated prize, a cherry. Sweet. So again, I have won a cherry. It might even be a Rainier cherry, which would be my favorite. And I can go home a happy man. So there's an example of how you can use the interop activity to help integrate your existing 3.0 activities within a 4.0 workflow. To give you an example of how to link the system together end-to-end to provide a fully customizable experience, taking full advantage of all the workflow technology, I'd like to introduce Jared Jackson. He's going to show you a real app that was not hacked together in a weekend like mine about how to deal with scientific workflows. Jared, the clicker is yours.
Thank you, everybody. And thank you, Kenny, too, for this opportunity. My name's Jared, as you heard. I'm from Microsoft Research. I'm in actually a very exciting group in Microsoft Research. Our group's called External Research. We get to work with the scientists and the various institutes and universities out there doing a lot of fancy research and everything from oceanography to geoscience to anything you can think of. And it's our task to take the cool technologies that are developed here at Microsoft and turn them into tools that they can use when they're doing their research. I thought what I could do at this point is actually show you a couple of the projects which we're working with, and then explain why exactly Windows Workflow is such a great solution for them, and then show you what we've done to give them activities, runtime, and some tools as well. And that feedback is probably the power to my monitor. So let me unplug that. All right, the very first project which we're working with is something called Neptune. It's run by the Ocean Science Initiative and is funded by our government. And it's a project we do with the University of Washington. What they're doing is they're trenching in huge network cables in the bottom of the ocean to go out and study what it makes up 2/3 of our planet, to learn a little bit more about climate change, to learn a little bit more about weather, and just to give us a way of knowing exactly how the changes out there affect our world. One of the things that's really great about this is there's this huge deluge of data that comes in from the ocean, and they need to process it somehow. Well, science is more and more about computing, and Workflow helps them do that. Once they have that data and they've done the processing, they want to be able to share it. They want to be able to make visualizations of the various data that they get, and they want to be able to maybe tweak that. And they want to be able to do all of that without having to be a programmer themselves. And the componentization that Workflow allows you lets them do that. There's also a group called PanSTARRS. This is a group that operates out of the University of Hawaii. They've put together the largest digital camera in the world. It's taking a picture of the sky every night, and they're actually looking at the objects in the sky, trying to figure out exactly where they are at one point in time and where they are the next point in time, and figure out what exactly their trajectory is. And they're curious about that because they want to know whether that trajectory is going to hit Earth or not. So you can imagine we've considered even writing a Call Bruce Willis activity to save the planet, just in case. Now you can imagine, though, that this is a very different kind of processing computation that has to be done on top of another large set of data. It has to run thousands of workflows every night, and all of those things have to be able to be fault tolerant, to be able to recover using other workflows, and to be done on a cluster system. So we're using all the great activities that are built into Workflow and adding a few on top of our own to be able to enable them to do this science. Now let me show you the tooling that we're doing. The tools that came with Visual Studio and Workflow are great tools, but the scientists need something a little bit more. They have some very particular needs. So we've built a product called Trident, which we're going to fully develop and then open source for the community to have. Trident has a few features with it. One of those things is that it has a workflow library. And you can work from your particular domain. You can import things. If you're interested in oceanography, you can have a lot of oceanographic workflows. If you're interested in astronomy, you can have that as well. What you basically can do is then bring those workflows over to a composition space. And that composition space is very data intensive. And I'll show you this working in just a minute. On top of that, we have activity libraries. And we have a lot of services on the back end. So we can take the provenance, the changes that you made. We record every change that you make to your science so that you know if you've done some experimentations that have gone awry, you can always back up and come back later. Persistence helps us with that. Let me switch over to my computer real quick. It's $20 here. They've actually run this before. There's $40 up here. All right, this is Trident. This is actually I assume, yeah. This is a simple workflow that we put together for the Oceanographic Institute. It's actually working on actual data, scientific data coming in a .NET-CDF file. If you're an oceanographer, you know exactly what that means. There's 3 steps to this. And it's very common for a scientific application. It reads in that data. It then does some sort of processing on that data and ends up with a result. So what you're actually seeing here on the left is a very data-intensive application. I've told it what file it's going to go read. There's a file off on my computer. It's going to generate a hypercube. which is another thing you'd be familiar with. And this last step here actually turns it into a more flattened state, a data table. Well, I have a lot of things, a lot of options I could use to modify that table and present it to myself. One that would be very useful in a demo would be to take that and turn it into a chart, which we can look at. So I'm going to grab an activity, which charts a data table, and I'm going to just drop it right in there. And I notice that the output from one of my activities is the data table, and I need to hook that up to the input to this charting activity. Now see, this is why we've customized it, because scientific workflows are very data intensive. And I'm going to set that I want to see a bar chart. I'm going to click OK. Then I should just be able to go up and execute my workflow. I actually have to save it. That's the versioning stuff. It has been saved, and it should now be running on my computer. Now, we've actually made this so it's distributed. You can launch a workflow from any computer that you have access to, and it should just start running on that computer. It will launch on mine, and there you have it. That's the salinity level in the ocean in 2005. There you go.
Great. Thank you, Jared. There's a bunch of cool stuff that these guys are doing. They're in the Slick Applications booth. So go into the big room and go check out the rest of the Trident stuff. They've got learn more about astronomy and avoiding comets. So this visual stuff, we love visualization of software and interacting with these boxes and lines. But occasionally someone goes up to me and says, hey, Kenny, I got a sequence, you got a while. Why do I have to drag these things onto a canvas? Why do I need to program with pictures and program with mouse clicks? Well, so to answer that, I first want to take a step back and introduce you to one of my favorite products, especially lately. I've been getting pulled from development into PDC, as you've noticed, and I've been spending a lot of time with PowerPoint. And the beauty of PowerPoint is sometimes I really want to express myself using text. Text gets my point across. All right? Sometimes it turns out that a visualization is the better metaphor to say what I want to say. And the beauty of PowerPoint is I have both of these facilities available to me. Right? I can use text in some cases. I can use visuals in other cases. And the beauty of workflow is because it's all structured data underneath, you can express what you want to in the way you want to express using visuals, using text. Because it's all structured data underneath, you get to choose your representation. So, to show you what it might be like to author an activity, such as a sequence of while loop type stuff, we're going to go back to our favorite app, except you're actually going to see the first source file. Turns out when we were running through this, we realized the fonts for the code were really small, but we hadn't noticed all the time because we didn't get to any source code until this last app. And what we have is, remember that prompt exact activity that we modified in an earlier demo? It was really just a while loop, all right? And in that while loop was a sequence, and within that sequence was a set of activities that would then go prompt and assign the results to a local variable. Now, that's one way to articulate yourself. Turns out, using some technology that we have available from the Oslo M team, and you'll learn more about all of the M technologies later this week, we were able to write a workflow-specific grammar to say what we wanted to say using a text-based format. So what you have here, it's an activity. I called it an activity. We can write customized keywords in the M grammar space. I call it prompt exact. It takes two strings, just like that visual activity. And I have some variables. It has a while loop. I can call other activities within this language. In this case, I'm calling the prompt activity. I can persist. This activity can get unloaded. And again, I'll check a simple condition. So a very natural expression for this type of activity. And if we go through and we run our grammar parsing tool, what you'll see is, starting with this .wf file, it generates a XAML file associated with it, just like the visual designer can generate a XAML file. And to show that, again, it's all structured data, we can then bring that resulting XAML file up in the designer. So again, whether you want to author with text or whether you want to author with pictures, DubF is a tool for you. Let's go back. So in summary, as you guys probably know by now, workflow is art, it is activities, it is runtime, and it is tools. Workflow helps you coordinate work, pushes complex coordination into the platform, helps you write persistable apps, gain visibility into those apps, and customize the vocabulary and design experience as you please. There's a bunch of related talks this week. I'll leave the list up on the board for you to check out, and let's go straight to Q&A. Thank you for your time, everybody. So for those of you that actually want to stay and ask questions, we have the room for a little while. We'll then go outside. Just come to the mic or come to the stage. Anytime now.
So one question I actually
What?
have, so
Yeah, I'll be here. I think we're going to the informal section. That's fine. Fireside chat.